Can you hear me? Yeah. Great. My name's not on here. I'm Kevin Deieling. I'm the VP of Marketing of Mellanox Technologies. 1 second here. Let me feel comfortable. So, all right. So now I'm ready. I'll put my jacket on. So, I'm going to talk about Snap Composable Storage made simple. So we did an announcement earlier this week on Tuesday and talking about our Snap. So I'm going to walk through what we announced and what we're showing in our booth. So sort of the backdrop for all of this is the 1,000-fold increase in performance that we've seen with storage over the last decade or so. So moving from hard disk drives to flash memory, first SATA and SAS, and then NVMe, and now new persistent memory, we've really seen a massive improvement. And as we like to say, faster storage needs faster networks. So Mellanox really drives the high-performance networks that help connect this. So we love all of the flash vendors out there. Very happy about that. Keep building faster and faster flash, and we'll keep building the faster networks to connect it. So one of the things that we think is important there is really not just the performance, but also some of the key backbone. And I'll talk about that, what we need in the network to make that happen. But before we do that, I stole a slide from my friend Roland at Pure. So they just published a blog, I'll show some more of it, talking about a new NVMe platform for their all-flash array. And really, I thought he did a great job of highlighting the inefficiencies and the problems associated with direct attached flash. And the big one is really how do you match the amount of storage you have in a server with the workload. Sometimes you'll have workloads that need lots of storage, so they're data intensive. And other times you'll have compute intensive workloads that need less storage. And this is dynamic. The workloads are changing over time. So making that happen, one way to solve it is just over-provision every server in your entire network with lots and lots of flash. But obviously that's extremely expensive, particularly at scale. So you end up with inefficient consolidation of running these things. So the other thing is if you have everything inside your box, it's hard to add lots of nice services. You can have local RAID, but how do you do erasure coding? How do you do mirroring, replication? How do you span across networks? So all of that becomes a challenge. And then you have different management APIs depending on which version of devices you're using, SSDs, and which versions of software, hypervisors, et cetera. So one of the solutions that we see here is NVMe over fabrics. And Pure was an example, but really there's lots of them. We think this is the technology of the future. There is no fiber channel in the cloud. Everybody's moving to Ethernet. So NVMe over fabrics, in our case, we think Rocky is really important, RDMA. We think that doing NVMe acceleration so that you don't have to burden the CPU to manage it, and really having a zero packet loss fabric, just like fiber channel has, but delivering that on Ethernet. So we think all of those are really important. We've done a ton of things to optimize the performance of NVMe over fabrics. So again, I'm going to go back to that blog that Pure published. So Direct Flash was their product. They highlighted exactly the sorts of advantages they see. And if you look at it with NVMe over fabrics, 50% performance gain versus what you would see over iSCSI, 20% performance gain versus what you'd see over fiber channel, and I think they could have gone a lot more than that if they'd gone to the 100 gig. They could have shown even better performance. I think almost the most important number on this slide is 25% CPU savings. So you've got the most expensive part of your server and you're giving 25% savings of that. So really they give a good example here of NVMe over flash. Now I've given a lot of props to Pure because they wrote a good blog, but I really don't want to forget about some of our other partners and customers here. Really, there's a huge NVMe over fabrics ecosystem that's developed. Companies like Celestica and MyTac, who we've done announcements with our SmartNIC, Dell, EMC, NetApp, Pure, who's announced products, NetApp's announced products. We've got software companies. I saw some of the guys here from Accelero and E8 that are working on this. VMware has done some demonstrations and announced that they'll be supporting these things. So really, it's a very, very broad ecosystem. And if you're doing external storage, I would highly encourage you to look at NVMe over Fabrics. What we've done is really take it one step farther with our SmartNIC. And the starting point of our SmartNIC is actually our regular NIC. And we always are confused about what to call our regular NIC, which is the ConnectX. This is the ConnectX 5, for example, because it's a really, really smart NIC. It has all sorts of offload capabilities, starting with RDMA, accelerates NVMe over Fabrics, accelerates workloads like machine learning and big data. It's really good at processing packets, whether you're having an onload technology where the CPU does it, like DPDK, or an offload technology, which is our ASAP squared, accelerated switching and packet processing, which lets you actually let the NIC do all of the work for load balancing and sort of denial of service attack mitigation, et cetera. And security. So we're doing more and more security acceleration and making sure this is a secure environment. But what we've done with the SmartNIC is actually added 16 ARM CPU cores and combined that into a single chip. So it's an SoC that combines the best NIC in the world, which is the ConnectX, with ARM A72 processors and a PCI Express switch, all into a single piece of silicon. So we're showing this in our booth. We're actually doing demonstrations of the technology I'll talk about here in a second. So suddenly you have this really powerful platform. The ConnectX is doing all of these various offloads. And now we have these uncommitted cores with the ARM that are software programmable that can do all kinds of clever things. And the first really clever thing that I think we've done and are now delivering to the market with this announcement is this technology that we call Snap that I'll get to in a second. So lots of different things we can do here. I'm also going to talk about the security portion of what we've been able to do. This is really a computer, and what we're going to do is put a computer in front of the computer that I'll show you in a second. So I've talked about offloads. Some people understand what it means. But in the old days, when we sort of had bare metal classes of servers, we have these multi-core processors that started to develop. And almost exactly at the same time as multi-core processors, we saw VMware said, hey, we should virtualize those because we can present each of those as a computer. And then right after that, we saw, let's virtualize other things. Let's virtualize the network. Let's virtualize the security. So we started off with multi-core processors, all of which were available to run the application. And then we moved to this software-defined world, which is great. The software-defined world is fantastic. It gives you agility, it gives you scalability, it gives you flexibility. And there's only one problem, is that you ended up burning up all of these CPU cores to run software-defined storage, software-defined networking, software-defined security. And suddenly you took the most expensive part of your server, which is your CPU and your memory subsystem, and people are saying, let's do NFV, Network Function Virtualization. That's great, but I can only get 8 or 10 gig performance out of a really expensive server because I've chewed up all of my CPU cores running packet processing. So what we do at Mellanox is build accelerators that actually give the CPU cores back to run the application. So we build SmartNICs and smart fabrics that actually offload all of those technologies and the security and the storage and the packet processing to the fabric, to the NIC, and then all of your CPU cores become available to run the application. So the great news, and this is why we've sort of become the market leader in SmartNICs and NICs, high-performance NICs, is that the cloud guys understand this. They're actually selling those green boxes to their customers. They're selling virtual machines. And to the extent that they can sell more of them, it rips right down to their bottom line and they make more money. So they understand that the network is really critical to being able to offer more efficiency, more services to their customers. So this is the backdrop of acceleration that we've really pioneered. And with that, I'm going to switch on to what we announced this week, which is Snap. Snap stands for Software-Defined Network Accelerated Processing. And in this case, what we're announcing was NVMe Snap. So Snap is a general concept that we can accelerate and virtualize things, I/O, And NVMe Snap, we've done it first with storage. So we really make composable storage a snap. So again, starting with sort of the original servers, you've got NVMe drives that you plug into that. And there's a PCIe bus, and it discovers an NVMe drive. And that's local storage, physical local storage. And we talked about some of the problems associated with direct attached storage and the limitations of that. What we actually are doing is taking the SmartNIC, putting it into a server, and now we can go access remote storage through the network. But we actually make it look like it's on the SmartNIC. We make it look like local storage. So you're accessing local storage, but in fact, behind the scenes, NVMe over Fabrics is running, grabbing storage from wherever it needs to, and making it appear local. So why is that interesting? There's a couple reasons that it's interesting and useful. So first of all, if you look at this, we have all of the benefits of network storage, but with the simplicity of local storage. So if I look on the left here, to do the same thing, you'd need some local disks, and you'd need a network card. What we're actually able to do is combine those functions into one card. So when you discover the NIC here, the SmartNIC, it says, what are you? It says, well, I'm in local NVMe storage. There's storage here. In fact, we're going across the network to get that storage and making it appear local. Any hypervisor, any OS doesn't need to know anything about NVMe over Fabrics, doesn't know that it's happening. It's running local access to storage and accessing data that happens to be remote. But on top of that, we can actually have a network connection too. So if you look, the 2 cards is really one. We're giving you 2 cards for one. So when the operating system, the hypervisor, discovers, it also finds a network interface card, dual 100 gig ports in this case, that goes out in the network. So you have network connectivity, you have local storage, all combined into a single card. And it's transparent entirely to the operating system, discovers, just like anything else if you had 2 of those cards in there. So you get sort of a 2-for-1 deal. On top of that, as I said before, we've put a computer in front of the computer. And we've really put a fence now between the application processor and the SmartNIC. And I'll talk about why that's important next. So what does this look like from an application perspective? You've got a server there, and it has some locally attached storage, which is there in blue, and it's got a SmartNIC in it. And I have a thermometer there that's saying, hey, how much of my local storage have I used? And you can see the server on the left has used all of its storage. It's running a really data-intensive workload, maybe an AI or machine learning workload. And it's used up all of its local storage. But if I look out in the cloud, in the data center here, there's lots of other nodes that have very underutilized storage. There's some of them barely using their storage at all. So when we say composable storage, this is what we're talking about. You have a set of resources in your data center, and you want to be able to mix and match to whatever workload you're running. If you need more compute or what the ratio is that you need, you want to be able to compose that dynamically on the fly. So we think NVMe over Fabrics is absolutely the ideal way to do that. So you have this smart Ethernet cloud fabric that allows you to do that. There is no fiber channel here. This is a single integrated network. And now what you can do, if you could combine the best of locally attached storage with the best of network attached storage that was dynamically composable to match your workload, all of your resources in the cloud could be used and made appear to be local. You could add all sorts of services in that smart cloud. So encryption, deduplication, thin provisioning, compression we heard about today, this morning, all kinds of great things, and make remote storage appear like local, completely transparent to your operating system and your hypervisor. So that's sort of the magic of Snap. What it looks like here is I can take these resources, disks, storage that isn't being used, and I can logically map them onto my local server. So now I have exactly as much storage as I want for the workload that I'm running. And when I'm done running that, maybe I switch over and run a compute-centric workload. Then I can free these resources and put them back into the cloud for other people to use. So that's what Snap is. And we have some partners here that we're working with to be able to do that. So E8 and Accelero were part of our announcement. We had a customer there, which was JD.com, that talked about the benefits that they see for their cloud, for this technology, and that they're looking forward to deploying. So it's just about all sorts of good things, better utilization, transparency to the operating system, and also, no software that damage in terms of being able to run applications that weren't really designed for remote storage. But there's another really critical piece that we bring to the equation here, and that's related to security. So if you look at data center security in the past with enterprise security, it was really all about walls. So a lot of talk about walls lately. These are firewalls. And so you would protect the edge of your network in the enterprise. Now I call that an M&M security model. It's hard on the outside and soft on the inside. And the reason that it could be soft on the inside is because the applications that you were running in an enterprise were your applications. They're your own company's applications, and you trusted them. They were trusted applications. And so you had your CPU and your security policies and your applications, and you could protect what was going into and out of your data center, and everything was good. That's sort of the M&M model of security. If you look at what we're doing today, we've moved to the cloud. And all of a sudden, this creates new security vulnerabilities because it's no longer your applications, your trusted applications. It's your customers' applications. So they go right into the center of your data center. You welcome them in. How many VMs you want? How many bandwidth? How much storage do you need? And it's their data. It's their customer data. And it's not just one customer's data. It's lots of customers' data. It's competitors' customer data. It's very sensitive data. It's banking data. It's health record data. So suddenly now, what does that mean when you've brought in customer applications that aren't yours, that potentially you can't trust? Well, now you have the x86 CPU and your security policies and an application all in the exact same domain. And it creates a gigantic attack surface. The x86 CPU in the server is a gigantic attack because it needs to offer every possible service that anybody could ever use. And we've seen compromises of the x86. We've seen the Spectre bug. We've seen the Meltdown bug. We've seen backdoor channel bugs where they're using the baseboard management controller to take over a bare metal cloud and compromise the x86. Once you've compromised the x86, everything else is compromised because it's all in the same domain. There's one security domain. And so we bring a bad guy in, and bad things happen. Everything suddenly collapses here. Whoa. We go backwards. Okay, let's bring the bad guy back. There he is. So what we need to move to is what I call a jawbreaker security model. And the jawbreaker is hard on the outside and hard on the inside. So now it's not just about building a wall and having firewalls to protect the edge of your network. Your entire network needs to be locked up. Every single server needs to be secure. So how do we do that? And how does this relate to what I was talking about with Snap? We think really the only solution here is a SmartNIC. So if you look at this model, and if we add a SmartNIC to this, everything changes because we've put a computer in front of the computer. So when we put that computer in front of the computer, suddenly we can create a new domain. We can create a new security domain for storage and for network. And we can move all of the policies that you want to run as a service provider out of the x86 domain, where the bad guys are and the untrusted applications are, and put them on the SmartNIC that isn't controlled, isn't in the same domain as the x86 CPU. So suddenly, if somebody wants to access more data than the service provider policies allow, you stop it here. If you want to have more networking, you're going to run a denial of service attack and take down the entire cloud. We say, no, your individual users is only allowed to do so much. We can have all sorts of policies that are enforced at the SmartNIC level and take it out of the domain of the x86. So the combination of Snap which is the storage network virtualization, and the security together make a powerful thing. We've got customers that just want to use Snap. We have customers that just want to use this security benefit, and we have customers that really see them tied together integrally into one. So there's lots of different things that we're doing with our Snap to make storage composable. We're just started now. This is a new framework. As I said, I think this is really the first truly clever thing that's been delivered on top of this new SmartNIC platform, where we're delivering all the infrastructure that our partners can take advantage of this. The security's there. If you are a storage vendor, if you're a big cloud vendor, if you're a security vendor, please talk to us. This is a nice programmable platform. We're very excited about the technology that we're developing. Also want to encourage you to go to our booth. There we've got lots of other interesting things. We're showing the OCP 3.0 cards, the ConnectX-5 based OCP 3.0 cards. We have our Spectrum switches. We have Spectrum 2 there as well, running 200 and 400 gigabits per second switches, running Sonic, for example. So it's a very bright, exciting time for us, and we're looking forward to lots of great new things with looking forward in the future here. So thank you very much.